Okay, we're going to do Fall 2010 number 15 and Fall 2010 number 14. We're going to do them both. Number 14 has us looking at -1 plus the cosine of t, all divided by t squared. We have no way of integrating that on our own, and so what we're going to do instead, actually there's a lower limit of 0 issue here. What we're going to do instead is to take the series for cosine and plug it in. So cosine is 1 minus x squared over 2 factorial plus x to the 5th over, x to the 4th over 4 factorial, and so on. That's cosine of x. What we need is cosine of t, and then we need to add a -1 to that. We'll just replace all the x's with t's. And so cosine of t is 1 minus t squared plus t to the 4th over 14 minus t to the 6th over, 4 factorial, minus t to the 6th over 6 factorial. That's cosine t. When I do -1 plus that, I'll basically take all of this and add on a -1, and it simply cancels. So then when it's time to go and divide this whole thing by t squared, I can divide each individual term by t squared and have -1 over 2 plus t squared over 4 factorial minus t to the 4th over 6 factorial. And there's some more terms. That is going to replace our integrand, and we're going to integrate that from 0 to 1. There's some other terms there. So when we put a 1 in, or actually let's integrate, -1/2 t cubed over 4 factorial times 3 minus t to the 5th over 6 factorial times 5. And there's some other terms there that we evaluate from 0 to 1 to get -1/2. 4 factorial is 24. 24 times 3, 72. Next term, 6 factorial is 72. Oh no, 720, sorry. And that gets multiplied by 5. Okay. We want this to be within 1 over 100, meaning that the first term we drop off, the remainder, because this is an alternating series, the remainder will be smaller than the first term that you drop off in absolute value. And so we want the remainder in absolute value to be less than 1 over 100. And so the first term that we drop off is the remainder, and we're not going to get less than 1 over 100 until we get to this third term. And so we drop off that term to be within 0.01, 1 over 100, and the sum, the approximation, would be the addition of those two terms, which would be negative 36 plus the 1 all over 72. Common denominator of 72. So we times top and bottom by 36 to get negative 35 over 72. Okay. At the same time, we'll do number 15. We have this integral of the sum. It's up to us to recognize this sum, though. We know that e to the x is x to the n over n factorial inside the sum. We don't have exactly that, though. We have an alternating sign on that. And what that basically is, you can take these two together and think about it as negative x, the whole thing to the n. And so it's basically that negative x is replacing x. It'll give the alternating sign x to the n over n factorial. Okay, so that parentheses is represented by e to the negative x. That's the function. Representation. The series is the representation of that function. That whole thing gets squared, and you're integrating from 0 to infinity. Integrating e to the negative 2, actually multiply these when there's 2 a power, 2 a power. And officially we have to let a limit as b goes to infinity. Okay, the antiderivative of e to the negative 2x is negative 1/2 e to the negative 2x. But we'll be better off calling that negative 1 over 2e to the 2x. It'll be easier to treat it like that, so we can see exactly what happens as b gets large. Negative 1 over 2e to the 2b plus 1 over 2e to the 0 as b goes off to infinity. And the denominator is going to blow up. The whole thing is going to get very small. It's going to go to 0. And so it converges to a half. Doesn't matter what it converges to, just that it converges. Oh, they want us to know what it converges to. Yeah. So we get a half. And that was 15 and 14 together from fall 2010.